Today I will talk about the bridging, and this is my outline. Bridges are link layer devices, and it can learn by observing traffic. There are two types of the bridges, the transparent bridges and source routing bridges, and in this video I will focus on the transparent bridges. Transparency means bridges only rely on the MAC address, so it's totally transparent for the higher layer, and it's desirable because the end station can using the legacy protocols and don't have to be configured. There are three preconditions. End stations should not participate in bridging, and bridges must forward broadcast or multicast traffic and preserve 6 aspects of reliable transfer. And this is a database used for bridging. Firstly, the first one, the address, that means source and destination address of the station. And it also knows the port to reach that address. And bridges learn a new address is reachable, and if database is full, it will replace the least recently used destination addresses. So that's the meaning of the used and replace. Whenever an address in the database is matched to a source address, it will delete the least recently observed source addresses or set the recently seen flag. So that's the meaning of the seen and aging, and the standard aging period is 5 minutes. Flooding. When the traffic first starts and the database limited memory of the database, the flooding will be happened. And it means forwarded on all active ports other than that from which it was received. And there are three conditions the filtering will be happened, especially the first one, when the output port equals the input port. And for the bridge process, firstly, it will look up the source in the database. If it exists, record the port of arrival and mark it as recently seen. Else, create a new database entry. And next, according to some policy, it will filter out or discard some certain frames, such as when the output port equals the arrival port. And next, it will look up the destination in the database. If the destination is in the database, the frames will be forwarded. But on the other hand, if the destination is not in the database, the flooding will be happened. Redundancy can increase the reliability in the network, but the loops are inevitable. Loops are not good because of the duplicate receipt and the frames proliferate. And spanning tree protocol can deal with loops to guarantee the uniqueness of the link of switch. So firstly, we have to compare and choose messages. Messages mean bridge protocol data units, such as the root or the root port. And choose a message with lowest root ID, lowest cost, lowest transmitting bridge ID, and lowest port ID. That means lowest is the best. And this is the spanning tree protocol. Firstly, we need to elect a root by comparing the bridge ID. In this picture, for example, the B1 is the root. And then we have to elect the root port. For the B2, this one is the root port, and for B3, this one is the root port, and for B4, this one is the root port to the root B1. And the third step, we have to elect the designated bridge and port. For example, for the Z line, we have to compare these three ports, and we can find that the cost of this port is higher than both of these two ports. So the designated port may be this one or this one for the Z line. And the fourth step, we have to maintain the topology through the periodic advertisements. And the advantages of the bridges: simple to use and implement because of the minimal labor and disruption, and it's fast and only rely on the MAC address. Disadvantages of the bridge: such as the large addresses to classify and the implication of the broadcasting, because if there are many users and information in the internet, broadcast storm may be happened, and suboptimal routing. Yeah, and this is some sources about the bridging. So that's all. I want to talk about the bridging. Thank you.